All right, so we're going to prove that if a is an integer, then a times a+1 is even. So this basically is saying that the product of two consecutive integers is always even. And we could think about this like, what's 2 times 3? 2 times 3 is 6, right? 3 times 4 is 12. 4 times 5 is 20, and so on and so on. So the product of two consecutive integers is always even. So in our assumption, we don't know if a is even or odd, so we have to break it up into two cases, right? If a is an integer, then it can either be even or odd. So let's go ahead and start there. So prove case one, a is even. Okay, so if a is even, this implies that a is equal to 2k, where k is an integer. Okay, so now let's investigate a times a+1. So this implies that a times a+1 is equal to 2k times 2k plus 1, right? If we substitute a with 2k. And then we get, so 2k times 2k is 4k squared. 2k times 1 is 2k. And then we can rewrite a times a+1 as 2 times 2k squared plus k, right? 2k squared plus k. And of course, 2k squared plus k is an integer, right? So we were able to write a times a+1 as 2 times an integer. So this means a times a+1 is even, right? Okay, so that's the first case. So now the second case, we're going to have a is odd, right? So we have, this implies that a is equal to 2k plus 1. Okay, so of course this implies that a times a+1 is equal to, so now we have to substitute 2k plus 1 wherever the a is. So 2k plus 1 plus 1, right? And then this implies that a times a+1. So, okay, I'll do this. 2k plus 1 times 2k plus 2, right? So instead of doing all that factoring, I mean, all that distribution and stuff like that, what I notice is I have a 2 here and a 2 here in this part, right? So what I can do is I can rewrite a times a+1 equal to 2 times 2k plus 1 times k plus 1, right? Notice I took out the 2 from both of these terms and I moved it all the way up there, and I used the commutative property as well, right? Because maybe I could have put the 2 like here in between, but I can just move it over using the commutative property. So the reason why I want this is because I know this whole thing is going to be an integer, because 2k plus 1 is an integer and k plus 1 is an integer. So 2k plus 1 times k plus 1 will definitely be an integer, right? And then I have a times a+1 is equal to 2 times an integer. So this implies that a times a+1 is even, right? So look, regardless of if a is even or if a is odd, we know that a times a+1 is going to be even, right? So um, in either case, a times a+1 is even, right? And that's what we wanted to prove, QED.